All right, gentlemen, we have another kicking problem, and I'm trying to give some general instructions as to how to do this and review the things that we went over in class today. So here we go. We have a kicker who punts the ball from his own 35-yard line. If the ball is kicked with a velocity of 23.4 meters per second at an angle of 34.2 degrees above the horizontal, let's fix that right now. And let's see what we can do with that. There it is. Above the horizontal. Answer the following questions. A, what are the velocities of this kick in the X and Y direction? B, assuming the returner calls for a fair catch, will the ball be caught between the opponent's 20-yard line and the goal line? In other words, how long did the kick go? C, what is the hang time, total time in the air of this kick? And D, what is the maximum height of the ball? Things we all did in class, but let's review. So the velocities in the X and Y direction. So here we have our kicker. Nice, isn't it? A little bit of screen magic there. Kicking, okay, maybe it looks like it's just 35.5-yard line. Whatever. So there's our kicker. And let's see what we have. Let's draw a quick sketch of what's going on here. We have obviously Vy and Vx. We have a kick. (23.4 meters per second). The angle is 34.2 degrees. So we don't know what are the velocity in the Y direction, velocity in the X direction. X direction, Y direction. Let's do the Y first. The Y is opposite the angle. So for the velocity in the Y direction, opposite, we have the hypotenuse here. We have the angle. So that would be so. So the sine of the angle is equal to the opposite side, which in this case is going to be the velocity in the Y direction, over the hypotenuse. The opposite side, velocity in the Y direction, is equal to the hypotenuse times the sine of the angle. Velocity in the Y direction is equal to 23.4 meters per second divided by or times the sine of 34.2 degrees. Velocity in the Y direction is 8.19 meters per second. So that's the up part. That's the part that gets the ball into the air. Velocity in the X direction. Okay, now velocity in the X direction, that is going to be right here. And we can use, let's use Pythagoras. He doesn't get enough love in this class. So we're going to say that that side, we'll call it B, is equal to the square root of C squared minus A squared. That side, the velocity in the X direction side, is equal to 23.4 meters per second quantity squared minus 8.19 meters per second quantity squared. Velocity in the X direction is 21.9 meters per second. Looks to me as though this is going to be a very long but not so high punt. A lot of velocity in the X direction, not much velocity in the Y direction. Okay, so that answers question A. Velocities in the X and Y direction. Assuming the returner calls for a fair catch, will the ball be caught between the opponent's 20-yard line and the goal line? Let's find out. That means that's A. All this was A. Here's B. We want to know what the displacement is. There's our range equation. Initial velocity squared over g times the sine of twice the angle. Initial velocity is 23.4 meters per second at an angle of 34.2 degrees. Range equals 23.4 meters per second, quantity squared, over 9.81 meters per second squared, times the sine of 2 times 34.2 degrees. The range for the delta x is equal to 36.6 meters. Now, there are 0.914 meters in a yard. Therefore, the kick is exactly 40.0 yards. So if he starts on his 35, and he kicks it 40 yards, the ball goes to the opponent's 25-yard line. So it is no. He does not catch it between the 20 and the goal line. Sorry. Part C, what is the hang time? Which is the time it's in the air, time it takes for it to go up and come down. So it's going to be delta t times 2. Remember, this motion is all in the y direction. So we have delta t is what we're looking for. Initial velocity in the y direction is 8.19 meters per second. Final velocity in the y direction is 0 because it stops going up, right? Stops going up, and then it comes down. So final velocity right there is 0. Delta y, that's how high we want it. Oh, no. Eventually we want to know how high it goes. And the acceleration obviously is negative 9.81 meters per second squared. Delta y missing. df equals vi plus a delta t. 0 is equal to 8.19 meters per second plus negative 9.81 meters per second squared times delta t. Negative 8.19 is equal to negative 9.81 times delta t. Divide both sides by negative 9.81. Delta t is equal to 0.835 seconds. That's how much time it takes to go up, times 2 is equal to 1.67 seconds. Hang time. Not too good. for a 40-yard kick. There's going to be some good return on that one. Finally, question D asks us, what's the maximum height of the ball? Remember, we have all the variables from up above here. So we're looking for delta y. So there's a good equation. Delta y equals 1/2 VF plus VI times the change in time. Now remember, this word about the height, so we're only going to use this time, that delta t, because that's the time it takes for it to get to the height of its path. So delta y is equal to 1/2, final velocity is 0, plus 8.19, remember this time, meters per second times 0.835 seconds. Delta y is equal to 3.42 meters. Wow. That's not very high kick at all. That one will probably get blocked. So there you go. So that's how you solve those 4 types of problems. I hope this has helped, and give me some feedback. I'd like that.